and germs, welcome back. I actually ended up falling asleep on the earlier stream, but I'm gonna go through the C programming language again. And I believe, in my opinion, the reason I'm doing it is because the C programming language is super important. It's a very powerful language. In fact, it's very close to it's the one of the lowest languages you can get to, and there's different levels of this, right? You got assembly language, which is responsible of literally everything a computer does, right? It's the main programming language outside binary, right? That's binary assembly language, and then assembly language to C, and then C is used to build operating systems. It's used to build interpreters of other programming languages like Python. It was used to build Linux. It was used to build Windows. It was used to build, you name it, right? The C programming language is the main language used to build almost everything you see on a computer, right? From all these little like GUIs to the way that the operating system itself works, etc., etc., right? So I want to kind of remind myself, a C program most of the time is written in one file, and everything's procedural. So you would program everything from like the bottom on down. Where object-oriented programming, instead, you can actually make multiple files, and then you run it from the main execution point. And every programming language has a main execution point. As we see here on our Hello World example, if you look down, this right here is our main execution point. So everything that you run would be here. And it's the same thing with Python. It would be the same thing with Java. They all have a main execution point. And again, like, this is a procedural language, so we're gonna learn a lot about this. And I kind of want to remind myself how to use this programming language again. I use Python. I use C++, and I want to use C again just to kind of remind myself, because I might actually get into exploit development, and I might show you guys how that works. And C is one of those programming languages that is actually exploitable just because of the way that it handles memory and everything is manual. So definitely I'll do a video on that eventually sometime soon. But for now, I want to kind of go through this from the beginning all the way to the end, as they say. So let me go back one more page. So we're going to be learning the basics, as you see here, right? So we're going to learn the hello world. So in other words, the structure, and then the variables and types, and then the arrays, and then the multi-dimensional arrays, conditions, strings, for loops, while loops, functions, static, and then the advanced stuff. Remember, I'll send you the memory pointers, structures, function arguments by reference, dynamic allocation, more memory stuff, arrays and pointers, recursion, links, list, binary trees, unions, pointer, etc., right? So let's start off with the beginning. But before we do that, I want you to check out the site. Look, it's called learnc.org, right? So let's click on Hello World, back to the page we were just at. So here, it's showing us the structure of how the beginning of the program will look. Hello World introduction. The C programming language is a general purpose programming language which relates closely to the way machines work. Understand how computer memory works is an important aspect of the C programming language. Although C can be considered as hard to learn, C is in fact a very simple language with very powerful capabilities. Nothing is truer than the statement here. C is in fact a simple language with very powerful capabilities. And by C is a very simple language, I'm pretty sure whoever said this got the hang of the language very well. But this is definitely facts. It's a very powerful language. It can do a lot of stuff. C is a very common language, and it is the language of many applications such as Windows, the Python interpreter, Git, and many, many more. C is a compiled language, which means that in order to run it, The compiler, for example, GCC, I believe it's the GNU C compiler or Visual Studio must take the code that we wrote, process it, and then create an executable file. This file can then be executed, and we will do that what we intended for the program to do. Our first program. Every C program uses libraries which give the ability to execute necessary functions. For example, the most basic function called printf, which prints the screen, is defined by the stdi.h header file. To add the ability to run printf command to our program, we must add the following include directive to our first line of the code. So one thing that's pretty known about programming languages is that they have, I guess you would call, they're called library functions, but I guess you could think of them as APIs, right? So this here will be at the very top of our programming file, and it'll give us the ability to use the functions that are here on this library, right? So for us to print something here, which would be printf, we would need this up here. So this is giving us the ability to print the code in our compiler. So that'll start making sense, right? So the second part of the code is the actual code which we're going to write. The first code which we will run will always reside in the main function. So the main function is the main execution point. It'll always be this one, integer main, and then this, our code, right? The integer, the int keyword indicates that the function main will return an integer, a simple number. The number which will be returned by the function indicates whether the program we wrote worked correctly. If we want to say that our code was run successfully, we will return the number 0. A number greater than 0 will mean that the program that we wrote failed. For this tutorial, we will return 0 to indicate that our program was successful. So as you can see, that it makes sense, right? Integer main, and then we're going to put the return. So what this means is that the program was executed successfully. So hopefully that makes sense to you guys. So let's start the exercise. So here, what I like about the site is that it has its own compiler already that we could use. So as you can see down here, right? One thing I like doing is that for me to remember all of this, the structure of the main program, I like to delete it. Well, first I copy it, and then I like to delete it. But first I like to remember how it's structured, right? So we were talking about the library, right? Up here, with this, we needed to run the printf, right? And then inside of, we obviously see goodbye world. We see the parentheses, goodbye world, and then the semicolon, and then these symbols here, this one. So that's how you successfully print out goodbye world, right? And then to tell the program we ran a successful compilation where we didn't mess anything up, we do return 0 and then semicolon right there, right? All within inside this integer main, symbols, etc., right? So let's do it. This is a single comment. So we're gonna learn this as well, right? So I always like putting comments in code. So as you can see here, 2 forward slashes means that it's one single line of code, one single line of comment. So I'll show you again. This is another single comment, and then let's do this. Include the include directive. Include more symbols. Honestly, you know what? Hold on. I forget the name of these symbols. So let's go through them. Symbols in the C language. I want to be, you know what I mean? I just forget the names of some of these things. Alright. Special symbols in the C language. In the C programming language, generally the special symbols has special meanings. So I guess these are called special symbols. This language provides low-level access to the memory and is identified by performance and efficiency. The C language includes a character set of English alphabeticals, digits, and specific meaning with special characters. Some special characters are operators, while combinations like parentheses are escape sequence, and C symbols are used to perform special operations. Some of the special symbols that are used in the C programming language are as follows, right? So here we go. These are the names of them with the examples. Brackets, right? Opening and closing of brackets are used for array element reference, which indicates single and multidimensional subscripts. So we're definitely going to see this right here. These are brackets, right? Especially in the arrays. So here, usually you're going to put a number reference here, right in between the brackets. So it could be something like this. It could be menu, right? Menu items. And then you put, let's just say 5. And then you assign whether it's an integer or a string, followed by the number, right? Let's just say you put 4. So it would be bracket 0 and then the equals operator, and then you assign whatever, right? And then it would be menu, and then you put a 1 and then an equals, and then you assign it again. We're going to go through arrays later. But now, what I meant to say was the parentheses. These special symbols are used for function calls and function parameters, right? Functions in C. So these are parentheses, right? As you saw, we saw it in our integer main, which was this one. All right, so hold on. Sorry about that. Let me see. Alright guys, sorry about that. I have to do this again, right? So as you can see here, these are the parentheses, right? So this usually defines a function. Let's go back. Are used for a function calls or function parameters, which makes sense, right? As you can see here, where we can also use it for this one. Brackets, which is used for the arrays, and then the parentheses, which is used for functions in here. And then these bad boys, let's get the name for these. Bad boy, what you gonna do? So colon, comma, right? So it is used to separate more than one statement, like separating parameters in a function call. A comma is definitely another popular used one, and definitely it's used to separate like parameters, definitely. And I believe you could use it to separate variables, if I'm not mistaken. And then colon. It is an operator which essentially invokes called as an initialization list. I haven't really used much of this one. Colon? Or colon? Semicolon definitely used a lot. You actually use it to close the end of a statement. It is called a statement terminator that indicates the end of one logical entity. That is the reason each individual statement must be ended with a semicolon. And then the asterisk. I don't believe we use this much, to be real. Assignment operator. This one will definitely be used. You could either use this to yeah, pretty much what it says. It is used for assigning values. So you could put, you could assign, for example, let's just say assignment, and then you put this assignment operator next to it, the equal sign, and then you could put 10, or you could actually put a string as well, right? So you could put assignment, and then you put the equal sign. Well, they call it the assignment operator, and then you can put hello. You know, my name is this, and it'll assign the hello, my name is this, into this one, and then the preprocessor, right, which we use for the library function up here. So this is a perfect example of everything we pretty much talked about. But these bad boys, I mean, arrow operators? No, that's not what that's called. Here we go. Looks like we found it. Angle bracket. Closing angle bracket. Ooh. So that's what it's called, right? An angle bracket and a closing angle bracket. So this is the angle bracket, and this is the closing angle bracket. So you put the function inside. Interesting stuff. Look at that. Alright guys, so let's go back to our programming page. So again, this is how it's structured. Again, it's learn, see, and hold on. I guess I forgot one, like a dummy. It's not tied. It's not. I don't even see it here either. Oh, the minus sign. Okay, I guess that's what it's called. So learn minus sign c.org. That's the name of the page if you want to learn how to do it. So let's run this bad boy. As you can see, bang, it worked, right? Look at the output. Tor, right? So I'm gonna do this print F. I'm gonna do it 3 times. Hello world again. Exclamation point. Let's not forget the parentheses and our semicolon, aka Terminator symbol. Let's do another one. Print F. Goodbye world. And then our Terminator symbol. Let's see, there we go. Hello world, hello world, hello world, goodbye world. If I'm mistaken, I think I can do this. I can give it space by doing this. But it'll run in the same line. So I think to fix that, I think we do this. Dang, that didn't work. Was it the backslash in? Let's do this. New line symbol C language. There it is. It was backslash. Fuck. Backslash N. Backslash N. And then again, if you do mistakes, what I love about these IDDs is that if you press Control and then Z, it'll correct your mistakes. So Control Z again. But sometimes, you know, if you go too back, you'll erase things that you got right. So let's do this, and then again, there's that, bang, bang, boom. Hopefully this works. Let's run it. Yes, sir. You see how now it's on the next line? That's what this is right here. The symbol will space it onto the line below it, and then the line below it, and then the line below it. So now, instead of it just being squished in one line, it looks like that. Alright guys, let's move on to the next one, next tutorial. So now the next one is obviously the variables and types. Data types. C has several types of variables, but there's a few basic types. Integers, whole numbers, which can be either positive or negative, defined using char, integer short, long, or long. Unsigned integers, whole numbers, which can be only positive, defined by using unsigned character, unsigned integer, unsigned short, unsigned long, and unsigned long. Floating point numbers, real numbers with fractions, defined using float and double. And then structures will be explained later in the structure section. The different types of variables define their bounds. A character can range from negative 128 to 127, whereas a long can range from negative 2 billion to over 2 billion. Long and other numeric data types have another range of different computers. For example, from negative 9 billion, oh, that's not even 9 billion, that looks like quadruple billion, quadrillion, or whatever that is, to 9 quadrillion, gabillion, gazillion on a 64-bit computer. Note that C does not have a Boolean type. Usually it is defined by using a following notation. Define bool character, define false 0, hashtag define true 1. C uses arrays of characters to define strings and will be explained in the strings section. That's interesting. It doesn't have a Boolean type. So if you guys don't know, a Boolean type is either true or false. And it looks like I'm looking at three options. I'm looking at define bool character, which I don't know. I don't know what that even means. Define false 0 and define true 1, which that's technically how it usually shows up anyway. 0 is always false and 1 is always true. That could be interpreted like that. So let's see what this. Let's ask Google what this means. What does this mean? Objective C. Why is bool a signed character? The other day, a user reported a bug to me about a toolbar item that was disabled when it should be enabled. The validation code, simplified for benefit, looked bool validation item and its toolbar item. Toolbar curly brackets ns array star symbol some array equals / star array from somewhere. Well, that's obviously a comment. Return some array count. It took me a few minutes to realize that the count returns a 32-bit unsigned integer, while bool is an 8-bit signed char. It so happened that in this case, the same array had 768 elements in it, which meant that the lower 8 bits were all 0 when the integer cast to a bool upon returning resolved to no. Even though a human could expect the answer to be yes, I've since changed my code to return some array greater than 0. However, I'm curious, why is bool really a signed character? Is that really better, or some way than being an int? That didn't, in my opinion, that didn't really answer my question. Is it Gemini? Let's see what Gemini has to say about it. Looks like nothing. There we go. Define bool char is a preprocessor directive in C that defines bool as an alias char data type. Here's a breakdown. Define, this is a preprocessor directive that tells the C preprocessor to perform a text substitution before the actual compilation. Bool, this is the identifier being defined. It's a common practice to use uppercase for macros, which are essentially text substitutions. Char, which is, oh yes, this is starting to make a lot of sense now. So what's happening here is that these are preprocessors. Remember how I was telling you the include is also a preprocessor, and it talks to a library function. So pretty much we're kind of doing the same here for that, but for some reason in the C programming language it doesn't have a simple just Boolean type, which you can do that. I believe you put Boolean, if I'm not mistaken, and then you put the equals, the assignment operator. You can put either true or false, or 0 or 1. It works the same thing, right? So as you can see here, so character means that you're just going to use one letter, and that could be either a number. No, actually, I believe it's just characters. Excuse me, I'm wrong. So it could be anything in the alphabet from A to Z. So I guess, or man, you know what? Maybe I'm wrong. Maybe it also, you could also include numbers as well. So that's why I see 0 and 1, because false is actually a string and true is a string as well. So yeah, that's how fun programming is, guys. That you gotta learn how to use this shit, you know. So that's fun, huh? Alright guys, so now we're gonna go through defining variables. For numbers, we will usually use the type integer. On most computers today, it is 32-bit number, which means that the number can range from negative 2 billion to over 2 billion, right? So it would be 2 billion, 147, 483, 648 billion, right? So etc., etc. To define the variables foo and bar, we need to use the following syntax. So integer foo, and then integer bar. So this one hasn't been assigned anything yet, but it is assigned an integer. It just hasn't been assigned a value. So here, integer bar has been assigned a value, and it's 1. So automatically this makes it an integer. So again, you can assign any number from here, right? So if you assign, for example, if you did integer bar and you try to assign it 3 billion, it's not going to allow you because you're past the bit type, right, which is a 32-bit number. So at that point you would have to use a 64-bit, which is long. That would have to be long, and then bar, and then you can assign 3 billion. So down here the variable foo can be used, but since we did not initialize it, we don't know what's in it. The variable bar contains the number 1. Now we can do some math. Assuming A, B, and C, and D, and E are variables, we can simply use plus, minus, and multiplication operators. And the following notation and assignment a new value to A. So integer A is 0, and then we use a little comma down here. That's what that's called, right? 'Cause you know I'm a dummy sometimes. Yes, sir. So then we comma B, assignment operator 1, comma C, assignment operator 2, comma D, assignment operator 3, comma E, assignment operator 4, and then the terminator symbol, which is the semicolon. And then down here, you're gonna, now you can reassign everything again, or actually now you are reassigning everything. So A, what you see here, is being reassigned everything up here, but now you're going to use math symbols to add all of the stuff up, right? So B minus C, so B is 1, and then C is equal to 2, so it would be 1 minus 2 will make it 1 again, plus D, which D is sine 3, makes it 4, times E, which is sine 4, so 4 times 4 is 16. And then print F, and here's some more special symbols, which I'm going to have to Google that once again just to know what the heck they are, because this is not a good job of telling us what it is. And then it's going to tell us the answer, right, which again will be 14. But for the fans, we're going to do this right now on our own, right? I'm not going to do this part right here. I know it's telling me to do it. Your code here. Hold on, let me see. Looks like it's already assigned stuff. 3, and then floating type, and then double type. Well, your code goes here. So if I had to guess, but it's not being specific with me. What do you mean? You want me to add it up, or do you want me to multiply it? Sum. Oh, it looks like it's saying sum of E. So maybe sum to me, add it up. So what we're gonna do, we're gonna do sum, and then we're gonna equal, and then A plus B plus C, terminator option, and then let's run it. My fear here is that because A is an integer, it might affect the program somehow, because B and C are double and float types. But let's see what happens. Correct. Click to move on to the next chapter. Oh, what the? I want to see what the answer is though. So it's 12.7500. So anyway, let's copy this and let's see what the answer is. I'll delete all this stuff. Hopefully it doesn't say wrong answer. That's not what I asked you to do. Again, I like pressing tab to get it where it's going. Tab. For this bad, we'll just use some spaces. And then run. 11, huh? That was wrong. Was it 14? Alright guys, I want to do something real quick. If you guys give me a second. I actually want to check something out. Just give me a second, hold on. Let me see, it hasn't popped up yet. What fudge not? That's not it. Come on, guys. Alright, guys, give me a second. I'm about to do something real quick. Dang, still nothing, huh? Fuck, man. Alright, guys, I was checking my my streams metrics. I just wanted to see who was watching, yada yada yada. Alright, so let's go back to the C programming language, which would be alrighty. I mean, the one thing that I could tell you guys is that I'm actually having fun, like remembering what C is, what it's about. I'm kind of like getting flashbacks. My first true language that I tried learning on, and I'm getting kind of flashbacks as well because the syntax is practically the same, is Java. I did a lot of Java stuff. And it's just a pain in the ass as it was. Like, none of this, like, Python is way easier. It's a lot less syntax. And then you see Kotlin, which is pretty much a Java Python. It's the same thing. It's just a programming language with a lot less variables. But it doesn't have the same capabilities as C. But it's a good programming language. You can still do stuff. It's not that bad. A lot of the programming languages out there are not that bad. It's just if you're willing to put in the work and if you're able to kind of do something creative with it. You know what I mean? If you're patient enough, I guess you would say. I would say that HTML and CSS, they can be a pain, but I wouldn't say those are programming languages. It's more like building a site, if I could say. JavaScript is actually a programming language, which is used a lot in web programming. So if you dive deep into JavaScript, you'll get a pretty good, a solid understanding of how programming languages work as well, and you can use those ideas in other languages like we are here. Right? So alright, so let's go to the next one, I guess. Even though I didn't really use much of the variable types, so let's actually before we go on, let's assign some of these data types, float, like individually, right? So let's do it on here. Let's do it again. I like doing it all. I like deleting it all and starting from the bottom. So again, include, and then stdi dot h, enter integer main, our main execution point, curly brackets, space again, tab, return 0 to make sure the program's running good. So now we're gonna assign different data types. Again, each of these, I don't know if you motherfuckers can still hear me. And or see me. OBS connection successful. Excuse my shitty internet connection. It comes, it goes, it works, it doesn't. Sometimes, yada yada yada. Blah 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 blah. So I don't know where the fuck I was. Oh yeah, I was talking about cars and integers and shorts and longs, etc. Right? So all these data types, they're assigned a number type in between. Car, it goes from negative 128 to 127. Long is even longer than that. So again, we're gonna have to use Google. Data types in C. Gemini was doing an okay job of explaining it, but I want to see the actual number types. Okay, so here we go. I guess we're seeing something now. So again, car type, which is this one, you can either assign it an A, but it has to be a single quotes, and or you can assign it a number from negative 128 to 127. Already went through that. And then the floating type can be assigned a number from negative. You know what? I hate when it gets fancy like this. Look at that. Range 1.2e to minus sign 38 to 33.4e plus 38, 4 bytes. I believe a byte is 8 bits. Of course, it's gonna do this to me. How many bits are in a byte? This is why, guys, I'm telling you, if you're gonna get into computers, it's gonna be a pain in the fucking ass, cause it is one thing taking you to another thing, to taking you to another thing, taking you to another fucking thing. So it's like you learn one thing, then you gotta learn another thing that's connected to that thing, and then that thing's connected to another fucking thing, and then that thing's connected to another fucking thing you gotta learn. Yeah, look at that. 1 byte, 8 bits, right? So this is 4. So it's a 24-bit fucking, let me see, where's this at? So it would be a 24, it's 24 bytes, 24 bits, excuse me, right? For the stupid float type. And then double, it's 8 bits, would be, make it a 24, or make it a, nah, that doesn't even make any sense. What? I am tripping. Oh my god. Nah, this is a float is a 32 fucking bit. 8 times 4 is 32. I am tripping. And then 8 times 8 is 64, which would be down here. So these fucking bytes are stored in memory. So these are so a double type, like down here, this is gonna be represented in memory as a fucking 32, as a 64-bit representation. You know what, guys? I just want to shut this shit down. I ain't gonna lie. Shit, man. I should be watching videos on fucking, watching guys in Afghanistan rebuild engines. I don't know why the fuck I'm watching this. I don't know why the fuck I'm doing this right now. This is too fucking much. And by the way, I want you to pay attention. What I'm doing is that I'm having a large picture on what's going on, which is good. I haven't really even programmed anything. I haven't done shit. I'm just trying to understand what the fuck the structure of the language is before I even do anything, which is fucking good. You have to understand what the fuck you're looking at, because a lot of the time, if you look at code, you're gonna be like, what the fuck is that? What the fuck is going on? What the fudge is this? What the fudge is that? Right? Look at that. A lot of people look at this and they'll be like, I don't know what the heck's going on. I obviously understand it. Every little thing is its own explanation to something in a programming language. This, and this. Everything, right? Alright, guys, well, you know what? I'm gonna continue my ghetto programming series tomorrow. Hopefully we get to learn more stuff outside, the data types, as we can see here. That's something that you could definitely go home and learn on yourself, since I haven't really skipped and or done anything yet that's useful.